Before we discuss anything else, though, I'd like to take you onto a tour of narratives. We have a piece of text here that explains that watching TV can improve the reading percentage by 5.3%. That's basically from someone who never reads to someone who reads every day. There's a 5.3 percentage point improvement in the marks. It also adds that every day is the best behavior. That is, students are scoring 47% at this kind of behavior. And never is the worst behavior, with students scoring 41.7%. It also adds that luckily every day is the most common. That is, this is what 67% of the students do. Let's try and create this narrative using FileHandler. The way we are going to do this is by taking this same piece of code and the same data and seeing how we can construct this piece of text. Let's start by saying the first one. This particular activity or impact can improve this particular subject by a certain percentage points. How do we do that? Well, let's say we add a paragraph at the end, and this says we have the impact. Well, let's copy this. Watching TV can improve reading percentage by 5.3%. Let's start replacing these with the variables themselves. That's nothing but the impact. But this was also in italics, so we'll give it an emphasis. We'll say EM and /EM. Can improve reading percentage is nothing but the subject. In our case, it might be social or something else by a number, and we'll worry about how we compute the number next. Let's see what this looks like. Okay, so reading a book can improve social percentage by 5.3%. If I change the impact to playing games, then playing games can improve social percentage. If I change the subject, it's reading percentage. And you can see that this 5.3% is clearly wrong because it's not changing, and we have to figure out how exactly we make that change. So what we want really is the difference in the average marks between the best, which would be every day in this case, and the worst, which would be never. 0 is where students have not given any information, so we really should remove this from our data set. So let's try that. What we'll do is this result that we show, let's start by removing the 0. What we'll do is assign this to result and show that result. But we'll remove the result, the 0 from the result. How do we do that? Well, this again uses the Panda structures. What we can do is take the results where the results index, that's result.index, that's effectively this column, is not equal to the string 0. All of these values are strings, so this is not equal to exclamation equals 0 as a string. This will give us a series that is either true or false. It will be true for the first row and false for all the others. So, not equal to, right? It will be false for the first row and true for all the others. So we'll get an array, a series really, which has false, true, 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 true. We can filter using that by saying result of result.index equals 0. So that will take all of those rows where the index is non-zero, and we can assign result back to itself. With this, when I reload this page, the entry with 0 should vanish, and it does. The other thing that might be convenient for us to do is to sort by the mean. So that way it becomes easier to see which is the lowest behavior, which is the highest behavior. So let's also do that. And for that, we use .sort values of the column name. In this case, we have the column name defined as two things. Remember, we had the group by aggregating by the subject, and within that getting the subject and mean, and also the subject's count. So in sort values, we actually have to put in a tuple that has subject and mean. So this will sort by the first column, which is reading percentage mean. Let's reload that. And we find that never reading a book gives the worst performance, at least in reading. And reading a book every day gives the best performance. And the difference between these is about 7 percentage points. Let's see if we can get that 7 percentage points out here. We'll call this gain, and this is nothing but the results first row, for which we can use iLog, which we can use iLog, which gives us the 0th element or the last element through -1. That will give us the whole row. We can also specifically take a particular subindex. So I can say subject, comma, mean. That will give me that particular column. In that column, I want the last value. Let's make this simpler for ourselves. We'll say set marks is equal to result of subject and mean. Now, just to get a feel for what this marks looks like, let's print it. And you'll see for yourself that marks, okay, let's put this in a pre so that it becomes easier to read. And yeah, so you just see that it has a single column with starting with never and going all the way to every day. So the gain is nothing but the last value of marks, for which we say that iLog of -1 minus the first value of marks, which is .iLog of 0. It's not exactly an array, it's a series, so we use iLog to get the positional indices. Now we can print plus. Now, let's just look at what the value is. This is nothing but gain, and let's render it. It says read a book can improve reading percentage by 6.598596 blah 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 %. Yeah, but I don't want so many decimals. Let's format this. We'll use the F formatting, the format string, and say that we want 0 decimals or maybe even just 1 decimal. That's good enough. Okay, I should have mentioned that we want a fixed decimal format, not the exponential. All right, so that says reading a book can improve reading percentage by 6.6%. Great. How does it improve my maths performance? Only by 2.7% between never reading a book and reading every day. Well, that's useful to know. The second sentence says every day is the best. Students score 47%. Let's add that sentence. So the next sentence, and we'll put this in a separate paragraph just for us to be able to easily read this. And this is in bold, so we'll make it strong /strong. And for this, we need to figure out which of these behaviors is the best, which effectively means the index. So we'll get the marks dot index of the last one, which is -1. And reload. It says every day is the best. It gets it from here. Students score 47%. Well, not quite. They actually are scoring 31%. So let's get the value there. In this case, it's marks.iLog of -1, the last mark that they scored. We'll put this in an F string again, and we'll make sure that this is formatted again with, again, I guess 1 decimal place, 0.1F. And reload that. Oh, looks like I missed something. There we go. So that's a 31.2%. That is the best score. All right. Let's also take the next sentence. Never is the worst. Students score 41.7%. That should be easy enough to write. So we take 0 and say is worst. Student score and put in a 0 here. With that, we have never is worst. Student score 28.6%. The next thing that we want to add is luckily every day is most common. Well, we actually only want to say luckily if every day really is the most common. What if it is not? What if, I don't know, let's take something like computer use. Okay, luckily once a week is the most common in reading. What about maths? Okay, so here once a week is the most common, but when it comes to improving computer usage, just not having computers is actually the best behavior. So we either want to say but if it is not the most common, or luckily if it is the most common. So how do we do that? At the very least, we need an if condition here. So if the best behavior is the most common one, so if um, every day, which is the best behavior, the last value is also the highest value, then we should say luckily. In this particular case, we should say but once a week is most common, because every day would be the best, but once a week is what most students do. So let's put that into the logic. We want to check if the count or the last row is the highest count. So let's do that. If, now how do we do this? Count of the last row is equal to the max count. Now, how do we get the max count? We have the result, and we can get the subject count. That will give us the column. And then we can do a dot max, which is a pandas series function that will give us a maximum value. Now, how do we get the count of the last row? We can say result of the subject and count column for the last row, log of -1. If these are equal, then we say luckily whatever. Else we say but whatever, and we end this. Let's see if at least it says luckily or but. It says but in this case. Let's change that to maths. Oh, this was already maths. Let's change that to science. And it still is but, because once a week is the most common behavior. Reading, not quite. Social, not quite. Let's change it to something else. Using computers, not quite. Playing games, not quite. Reading a book again. Okay, looks like we don't have, at least in Goa, many scenarios. Let's take playing games. In social, no. In maths, nope. Once a week, once a month seems to be the optimal behavior. Nor in science. What about in reading? Nor in reading, nor in social. Well, looks like we do have a problem here. We don't have any kind of scenario where the luckily is going to be displayed. What if we took it only for boys? I'm going to do a little bit of digging around here. Okay, with a little bit of exploration, I found one particular segment for girls who are 15 years old that have only one sibling. It turns out for them the everyday behavior, I mean, that's playing games every day, is also the best behavior as well as the most common behavior. And in this case, it says luckily. So our statement was working fine. Let's make sure that we put in the rest of the content. Something else is the most common. So this was for but it's all the same. So what we want here is whatever is the behavior, the impact. Oh, sorry, no, not the impact. We want marks.index of -1. So that is the label. The most common label is the most common. And same here without the comma. So now we get, didn't get saved. Okay, luckily index marks dot. Oh, what am I saying? It shouldn't have been index. It should have been iLock to get the last one. Let's reload. Yeah, luckily 42 point. Oh, okay. Oh, we want the result dot index. Or put an index at the end. Take the result, take the last row, get its index, and no, maybe dot index of -1. As you can see, I'm not as familiar with pandas as I like to be. And that works. Luckily, every day is the most common. What if we removed one of these constraints? Let's say no siblings. Just remove that from the URL. It says, but once a month is most common. We probably want that highlighted. So that in strong undo it as and then put in a slash strong. Similarly, we have strong and a slash strong here. So with that, we have a narrative that tells us that playing games can improve social by so much. Now, that is true only for a particular segment. We really have a series of filters here, and it's not clear from this description what this filter is for. So let's do this. What we'll do is put all of these, not as paragraphs, maybe the way we are doing it, but perhaps as bulleted list. We'll say, here's an ordered list, and all of these are list items. This is a list item as well. And this is a list item as well. So that should be centered. Class is equal to text left, maybe. Okay, well, let's just get rid of the centering that we have somewhere out here and move it all to the left. Just see what it looks like. Yeah, this is fine enough for me. Now, out here on top, we could probably say for this particular segment. Now, the kind of sentence I'd like to add here is for girls age 15 to 16 and nothing about siblings. That's literally the statement that we want here. So let's say we put in the text here for, let's say, girls aged something, let's say 15 plus, with no with, okay, let's say one sibling. That's what we had here. That's the text that should appear here. For this, we need to have all of the filters that we've selected, and that's effectively coming from these columns. So effectively, as we loop through the filters, we need to have these statements. So let's create these statements. Let's create an array called applied filters. And this is an array. If any of these filters are applied, then we will set this applied filter. As we loop through all of the filtered items, we will check if this particular filtered column is present in the URL query parameters. That is specifically in handler.args. And we don't necessarily have to do that here. We could even do that out here. Let's do that out here. What we'll do is loop through for the column in the same set of filter columns that we have here. Filter columns, which we'll define as variable. And as we loop through these filter columns, if handler.args has this, then we'll set the value to that as the applied filter. So if call in handler.args, what we really want to do is take the handler.args of column and take the last value from that array. And this is what will be our list of filtered columns. So let's look at how exactly we add it into the array. Girls, we really want to say, okay, what this will give us is an array that will say girls, comma, 15 plus, comma, one sibling. We need a prefix for each of these. So let's say filtered, not quite filtered columns, prefix and call in a tuple that has nothing for gender. The column name was capital gender. and a prefix of aged if the column is age, and a prefix of width, and the value is siblings. Well, with one sibling, with single child, it's okay. We can live with that. A single child, that's sibling. And given this, we now want to put in a string that has the prefix as well as handler, the particular handler value. Let's print this and see what we get. Unknown operator. Oh, this line doesn't need to exist. Reload. Right. So it's saying girls aged 15 years. That's precisely what we want with one sibling. So if we concatenate all of this, we'll get what we want and just put a for in front of it. What if we removed all of these factors and just took it for everyone? Then the array is empty. So it'll say for an empty array, which is not exactly what we want. Now it'll say for boys. That works. For aged 15 plus. That works fine. Age, well, I guess instead of aged, we probably would be better off saying age. And therefore the prefix should probably be just age here. And yeah, for age 15 plus years. What if we only had a sibling? So let's see. Now it'll say for with one sibling. That isn't quite good. So let's get rid of the with here and see what happens. For girl, age 15 years, one sibling. Yeah, it's not too bad. We ideally would like better grammar than that, but we can live with it. So now let's say we put in for. This is a paragraph for, and take all of these and join them with a comma. Or better yet, we'll take the whole thing and say that these are the applied filters for, and in quotes with a comma, join applied filters. And compare. Well, actually, let's even get rid of this. We don't need this anymore. This was a static example. See what we get. For girl, age 15, blah, blah, blah. We probably should have a space after this. Yeah. For girl, age 15 years, one sibling. And if you got rid of the sibling consort, let's go here. And for one sibling, okay. What if I wanted for three siblings? Okay. For single child, that's fine. For age 14 years, single child. For girl, ideally this should have been girls or boys. We can change that in the data itself. Now, this now reads like a proper narrative. For age 14 years, single child. Let's get rid of all of these filters. Okay, that is a little odd. So if there are no filters, we should probably just say for everyone. So join of applied filters, if applied filters is there, else just say everyone. And now we have a reasonable narrative here for everyone. And if we start applying filters for age 12 years and for 4 plus siblings, playing games can improve social by, okay, 9%. That's because there's really no data. But for age 12 years, playing games can improve social percentage by 3 percentage points. Every day is the best. Once a week is the worst. Luckily, every day is the most common. Fair enough. What we've done is taken Tornado templates and put them into FileHandler and applied the logic step by step to create a narrative. And what this helps us do is explain a visual to people in a way that they truly understand.